Task management. A task is the processing unit as seen from the CPU that will execute the program. In multiprogramming, there are multiple tasks being executed in main memory, so it is sometimes called multitasking. One task is selected from among these multiple tasks, and from the standpoint of the CPU, it is given CPU time. The role of task management is to give a suitable amount of CPU time, in arranged order, to the multiple tasks to be executed in multiprogramming and TSS. Among the multiple tasks, the task that is currently executed is in the running state. The tasks that are waiting for their turn to be executed are in the ready state. The tasks that are waiting for an input-output completion interrupt while in the middle of input-output processing are in the waiting state. Tasks usually go back and forth between these states until execution is completed. This is called task state transition. A job control statement can be used to assign priority to the respective tasks. Whenever all of the interrupt processes are completed, the task with the highest priority in the ready state is initiated or resumed by the task management program called the dispatcher. In switching the tasks to be executed in this way, it is necessary to save various information, such as the contents of registers in use. When the task is resumed, the saved information is restored. Next, the address of the instruction to be executed is set to the instruction address register, and its execution is continued. After that, the task can use the CPU time until some kind of interrupt is generated. The priority of each task can be changed or adjusted dynamically during execution. The following operation is used for this. 1. A real-time processing task is given higher priority. 2. Tasks with frequent input-output are gradually given higher priority. It enables the CPU to execute another task until input-output completion, and in addition, the task itself is completed in a speedy and prompt manner. 3. The priority of tasks with a low frequency of input-output is decreased, and a longer slice of CPU time is allocated to the task. The role of task management is to resolve some conflicting demands, such as guarantee of response time, effective use of limited resources, increase of throughput, and reduction of average turnaround time, by controlling the amount and frequency of allocated CPU time based on the characteristics of the tasks. In order to take this role, the task priority is adjusted in the way described in 1, 2, 3. Parallel processing on a task basis has become available under the control of task management. However, now a demand for parallel processing within the same program has come up. For example, let us say that you want to display a page with an image on the internet. If the image is large, it will take a long time. You have probably experienced pages that are slow to download. You might change your mind before the completion of download and want to look at a different page. In such a case, if you click the link to another page without aborting the current page download, both pages can be displayed on the screen simultaneously. In other words, parallel processing can be done within the same program. This cannot be explained by only using the term task. The thing that makes parallel processing possible within the same program is a thread. The thread first came out in the latter half of the 1980s. Tasks, or processes, are subdivided into threads, and each thread is allocated a CPU resource. However, each task is not allocated the other resources, such as main memory and disks, so the resources allocated to its parent task, or process, are used for the thread. Not all of the OSs can support the thread function. In OSs with thread, CPU is allocated on a thread basis, and memory and disks are allocated on a task basis. When tasks are switched, it is necessary to save the status information related to them. In some cases, the memory contents must be swapped, and it causes the additional load on switching. On the other hand, since threads can share the resources that is allocated to their parents, the switch load is reduced. Therefore, threads are used for the Windows family of OSs.